Good evening, children. Welcome to Akshara IIT Foundation. So this is Srinivas, your maths faculty. Let us go to the today's class. Okay. Right. So it's been long time to meet you. Right. So let us see that actually we are discussing the quadratic expressions or equations topic up to second exercise or second synopsis, right? So we need to complete the second synopsis today. So let us see the problems, remaining problems. Yeah. See the 13th question. If ax square plus 2cx plus b, first quadratic equation is given ax square plus 2cx plus b equals to 0, and second quadratic equation ax square plus 2bx plus c equals to 0 have a common root. Have a common root. Then we need to identify the value of b plus c. Identify the value of b plus c. So let us take the quadratic equations. Ax square plus 2cx plus b equals to 0, and second quadratic equation ax square plus 2bx plus c equals 0, and the condition is here b and c are not equal. We did not get the values are same for b and c, but we don't know the common root, right? So let the common root is alpha. Let the common root is alpha. Actually, root or 0 or root of the polynomial or 0 of the polynomial, both are same, right? That means when we substitute the value or root in the given quadratic equation, that equation becomes 0. Am I right? Yeah, that means that has to be satisfies LHS and RHS value. That is called root of the quadratic equation or 0 of the quadratic equation. Yeah, I am taking the root is alpha. Now I am substituting here in the place of x. I need to substitute the value of alpha. So let me write a alpha square. In the place of x, I need to substitute alpha. Yeah, plus 2c alpha plus b equals to 0. Okay. Now I am substituting in second equation also, because here both are having a common root. Both are having a common root. So I am substituting in second equation too. So that is also a alpha square plus 2b alpha plus c equals to 0. By elimination method, I would like to cancel first terms. A alpha square, this is also a alpha square. I am subtracting second equation from first equation. Okay? Yeah, I am changing the symbols. So plus a alpha square becomes minus a alpha square, plus 2b alpha becomes minus 2b alpha, and plus c becomes minus c. While you are observing this, first two terms are same, am I right? First two terms are same. So alpha square, a alpha square, both are same. We can cancel it. Becomes a alpha square minus a alpha square value is 0. Okay. Coming to this one, 2c alpha minus 2c beta. I am writing 2c alpha minus 2b alpha. Okay. Now here b minus c plus b minus c equals to 0. Right. Now let us simplify this. From first two terms, I can identify the common letters or common numbers. 2 is a common number and alpha is the common symbol between them. So I am taking 2 alpha as a common term from first two terms. So what are the remaining here? In first term c is remaining and the second term is b is remaining. So it is c minus b. That equals to b minus c, I am transpose that side. Minus c transpose becomes plus c, and plus b transpose that side becomes minus b. Okay? Right. That implies alpha equals to c minus b. This one 2 into c minus b. The entire term is multiplying this side. When you transpose that side, it is going to divide. So 2 into c minus b. Now observe here, numerator c minus b, denominator c minus b is going to cancel. Now alpha is nothing but 1 by 2. That means the common root is 1 by 2. Let us substitute in any one of the equation. Okay, I am substituting in equation 1. So a into alpha square. Alpha square in the place of alpha, what I should substitute? 1 by 2. So 1 by 2 whole square plus 2c into alpha. In the place of alpha, 1 by 2 plus b equals to 0. Equation 1. B equals to 0. Okay. Now just apply 1 by 2 whole square. That means the square should be applied for both the numerator and denominator. 1 square value is 1 and 2 square value is 4. 1 by 4. And here numerator 2, denominator 2 value cancel. C into 1, C plus B equals to 0. But what is the value we want? We want the value of B plus C. B plus C or C plus B both are same according to commutative property under addition. Okay, na? Yeah. Now C plus B. Here A into 1 by 4 is nothing but A by 4. So plus A by 4 transpose that side. It becomes minus A by 4. So our required answer is minus A by 4. Option 1. So I have just taken the common factor or common root as alpha and I substituted in the both equations. By elimination method, I found out the value of alpha, that is 1 by 2. That alpha value is, I am going to substitute in equation 1. You can substitute in equation 2 even though you will get the same answer. Okay, na? Because alpha is the common factor between both of them. Clear? Yes. So we want the value of a minus A by 4 is our required value. Yeah, please note it, children. Then we can go to the next problem. Make it fast. Yeah, I have taken so many holidays, so we need to complete. We have to run with the syllabus. Let us complete quadratic equations as early as possible. Okay, yeah, I am going to the next problem. See here, alpha, beta are roots of quadratic equation ax square plus bx plus c equals 0. This is nothing but a general form of a quadratic equation. Ax square plus bx plus c equals to 0. And we need to find the equation which are having the roots a alpha plus beta whole to the power of minus 2 and a beta plus b whole to the power of minus 2. Okay, na? Like properties or transformations of quadratic equations, we have learned some of the formulas. Alpha, beta are roots of ax square plus bx plus c. Alpha minus if alpha beta are roots of this, what about alpha plus k, beta plus k are roots of the equation f of x minus k. When you are taking plus k here, the required equation becomes f of x minus k. In such a way, if you are taking a alpha plus b, a beta plus b, what is the equation? F of, yes, x minus b by a will be the required quadratic equation, because plus b we are applying minus b and here a is multiplies a into alpha. Here a should be divided. This is our required equation. Okay. Let us find out that. Before that, if alpha beta are roots, what are the sum of roots? Sum of roots alpha plus beta value is minus b by a. Product of roots. Product of roots is alpha into beta, that equals to c by a. These two we are learning from the starting of the topic. Okay. Now f of x minus b by a value, let us substitute in the given quadratic equation. In the place of x, substitute the value of x minus b by a. X minus b by a whole square, because it is a x square, plus b into x, again x value, x minus b by a plus c equals to 0. Okay. Yeah, simplify this. The numerator is in the form of a minus b whole square, that is a square plus b square minus 2ab. Okay. So x square plus b square minus 2bx. Denominator also you should apply square. A becomes a square. Now here b into x bx minus b into b b square. Bx minus b square by a plus c equals to 0. Now while you are observing, a square is the denominator, highest power. So let us a and square cancel. The denominator a is the LCM for both of them. Then x square plus b square minus 2bx plus bx minus b square plus ac equals to 0. That means I am just multiplying these three terms with a. If you take multiply with a here, a and denominator a cancel. For second term also denominator cancel. Third term not there, denominator. So numerator a will be remains. Now cancellation of b square minus b square. Still what is remaining? X square minus 2bx plus bx. Both are like terms. One is negative, one is positive. Subtract. So minus bx. From 2bx, 1bx we should subtract. So x square minus bx plus ac equals to 0 are having the roots of a alpha plus b and a beta plus b. Okay, na? But we need to find out this value. Okay, now I am taking a alpha plus b is letter p. I am taking with letter p. This is taking with letter q. So simply we need to find p power minus 2 plus q power minus 2. P power minus 2 plus q power minus 2. Let us simplify here. When you have the exponent is in negative, we have to write in the denominator, right? We should express it in denominator. That means 1 by p square. Like q power minus 2? Yes, very good. It is 1 by q square. Now find LCM, it will be p square plus q square by p square into q square. Instead of writing entire term, I am just writing like this in the terms of p and q. Last I will change it. Okay, na? Yeah, p square plus q square value. Now I am writing that p square plus q square as p plus q whole square minus 2pq. So nothing but a square plus b square is nothing but a plus b whole square minus 2ab. Okay, na? Divided by pq whole square. That means the entire time I have written in the form of sum of roots and product of roots, where p and q are roots only, no? Roots of this equation. So what is sum of roots here? Sum of roots is minus b by a. So minus of, this is minus b. So becomes plus b. A value is 1. Product of roots, product of roots is c by a. In the place of c we have ac by 1. So simply sum of roots is b, product of roots is ac. Okay? Yeah. Substitute in the form of p plus q. P plus q means sum of roots. Sum of roots what? B. So b square. Now I am going to write here. So that is b square in the place of this minus 2 into pq. Pq is product of roots. Product of roots value ac. So in the place of pq we can write 2ac by pq whole square. Pq value ac. ac whole square means a square and c square. This is our required answer. First we need to identify the quadratic equation which is having the roots of a alpha plus b and a beta plus b. That is nothing but f of x minus b by a. Substitute and identify the quadratic equation and find out sum of roots and product of roots. Then solve this one in the place of root power, that means alpha power minus 2 plus beta power minus 2 expressed like this. Please note it. Yeah, let us go to the next problem. Right. If the roots of ax square plus bx plus c equals to 0 are both positive roots, both roots are positive and b value is less than 0. So according to the properties of quadratic equation, we have discussed about the roots. For this quadratic equation, product of roots c by a. If c by a value is greater than 0, then a and c always having same sign. A and c always having same sign. That means a value can be greater than 0, c value can be greater than 0. First condition, same sign. So they can be negative also, right? A less than 0, c less than 0. Both chances if product of roots value is greater than 0. In case c by a value is less than 0, a and c are having opposite sign. A and c are having opposite sign. That means if a value is less than 0, c value greater than 0, first condition. And if a value greater than 0, then c value is less than 0. We have already discussed in our previous classes, right? Yeah, here clearly given that both are positives. Both are positives and b value is less than 0. Now here you should understand one concept. If a and c both are greater than, b less than 0. If a and c both are less than 0, b value is greater than 0. But here given that b value is less than 0, so we need to choose the first option, a value greater than 0 as well as c also greater than 0. So our answer is 4. Okay, na? From the condition. So same problem is given also here. Let us see. Yeah, this one. If the roots of this both are negative here, both roots are negative. So what is the chances for us? A less than 0, c also is less than 0. Okay, na? Right. Now let us discuss with alpha, beta are roots. 16th problem. Alpha and beta are roots of the quadratic equation ax square plus 2bx plus c equals to 0, and gamma and delta, this symbol we should read as gamma and delta, are roots of ax square plus 2bx plus c equals to 0, such that these four are in the form of AP. AP is nothing but arithmetic progression. Arithmetic progression means we have discussed in our earlier classes, that is nothing but the term or sequence of or series of numbers are following a common difference between any two consecutive terms. First two terms having the common difference is 2, second and third term also having the common difference 2, third term, fourth term, 4 and 5, 5 and 6. All consecutive terms are following the same common difference. Okay, na? So such type of arrangements are called arithmetic progression. That series is in arithmetic progression. In same way, alpha, beta, gamma, delta, four terms are in the form of AP. Now we can take alpha minus beta is common difference between first two terms. That is equals to delta minus, gamma minus delta. Am I right? Because four of them are in arranging in arithmetic progression. First two terms difference equals to last two terms difference also. Okay, na? Yeah. Now, first two alpha, beta are roots of which equation? Ax square plus 2bx plus c equals to 0. Okay, na? Where alpha, beta are roots for this equation. Such a way, capital A x square plus 2bx plus c equals to 0. For this equation, gamma and delta are roots. And we know that sum of roots, product of roots, difference of roots like this. What is the difference of roots equation formula? Alpha minus beta formula? Yeah, say any one of you. Alpha minus beta. Yes, very good. It is root over b square minus 4ac by modulus of a. This is the formula for difference of roots. Sum of roots minus b by a, product of roots c by a, difference of roots root over b square minus 4ac by modulus of a. Okay, no? Now, I am substituting here alpha minus beta root over. Here b means what? X coefficient. X coefficient is 2b. X coefficient is 2b. B square means 2b whole square. 2b whole square means 4b square. Okay, na? Square of 2 is 4. B square is b square only. Minus 4ac. 4 into a value is small a and c value is small c. There is no change in it, and modulus of a. That equal to difference of gamma and delta. That is equal to root over. This is also b square value, again here 2b capital B. So 4 capital B whole square minus 4ac by modulus of a. Okay? Right. Now actually we need to find out the value of b square minus ac by capital B square minus ac. From these two, this is modulus of a. Okay? Modulus of a means whether it is taken a value negative, it will give positive value. Okay? Right. Now that means both sides, I am squaring on both sides, so I can remove the square roots. Squaring on both sides means without square root, it will be 4b square minus 4ac by modulus of a square means a square. That equals to here, without root 4b square 4ac by capital A square. Now while you are observing the numerator, both terms having 4 is the common term. Here also 4 is the common term. Now I am taking 4 as common term, b square minus 4ac by a square, that is equals to, here also 4 common term, capital B square minus ac. Sorry, here 4 not there because we have already taken common now. Here 4 won't be. Yes. Okay? B square minus ac by capital A square. Both sides 4 cancel. Now apply cross multiplication. B square minus ac by b square minus ac equals to small a square by capital A square. That is our required answer. That is 3. Okay, no? Please note it. Yeah, is it clear? Yeah, I'm going to next. Right. So x value is greater than 0. That means x value should be positive value. Then what is the value of x plus 1 by x? Value of x plus 1 by x. So let us substitute this. Least value of x plus 1 by x. X value we should take only positives. Now, if you take the value of plus 1 in the place of x, that means immediately 0. What is the first positive number? 1. So let us substitute here 1 plus 1 by 1. 1 by 1 means 1 only. I am just substituting in the place of x plus 1 by x. Okay, na? Yes, 1 plus 1 by 1 value 1, that is nothing but 2. So if I substitute the value in the place of x, I am substituting 1, first positive integer. Okay, so the value I got 2. Let us substitute 2 this time. 2 plus 1 by 2. 2 plus 1 by 2, nothing but half. Half means 0.5. 0.5 is nothing but 2.5. If you take 3, it will be 3 plus 1 by 3, that means 3 plus 0.3 something, 333 something. So the answer will be 3.33 and so on. That means if you're taking x value continuously like 1, 2, 3, 4 and so on, the x plus 1 by x value is increasing but not decreasing. So among them, what is the least value? Least value always comes when we take the least number, because x value is positive 0, greater than 0. Okay, na? So x plus 1 by x value is 2. Very easy problem. By assumption method we can identify this. Just substituting the values. Okay. The 18th one we have already discussed in previous. Quadratic equation, both roots are negative. C by a value is greater than 0, then only possible. Both roots are positives or both roots are negatives. In such a way, you should get that a less than 0 and c less than 0. Okay? Right. Going to the next. Yeah, very, very important one, this one. So let us see the ratio of the quadratic equations. Two quadratic equations. First one, ax square plus bx plus c equals to 0. And second quadratic equation is px square plus qx plus r equals to 0. Two quadratic equations are there. Okay. Now, d1 and d2 are discriminants. We have already discussed about discriminant delta. We are representing with the symbol delta or representing with the letter d. Discriminant equals to b square minus 4ac. And we have discussed the concept at there. If b square minus 4ac greater than 0, there are two roots. Two distinct roots equal to 0, two equal roots less than 0. No real roots we have discussed. That means imaginary roots will be there. It doesn't matter. So greater than, less than, equal to, three conditions we discussed. But here d1, d2 are discriminants. First d1, this is d1 only. I have written the discriminant for general form, b square minus 4ac. But what is the discriminant for here? B square minus 4ac, in the place of b we have q. Q square minus 4pr. d1 and d2 are discriminants of these two respectively. Then we need to find out d1 is to d2 value. d1 by d2 is how much? Okay, na? Now, if alpha, beta are roots and by gamma, delta are roots of the second one. Componendo and dividendo rule, I can apply alpha plus beta by alpha minus beta equals to gamma plus delta by gamma minus delta. It will give like this, because it is already given, both are in the same ratio. The roots are in the same ratio. For example, first equation I have taken alpha, beta roots. Ratio means alpha by beta. For second equation, gamma, delta, its ratio means gamma by delta. By componendo and dividendo rule, componendo and dividendo. From this rule, I can take alpha plus beta by alpha minus beta, gamma plus delta by gamma minus delta also gives the same ratio. Okay, na? Now, alpha plus beta, sum of roots, substitute sum of roots is minus b by a. Product of roots, difference of roots I have written here. Root or b square minus 4ac by modulus a. Okay, na? Yeah, same I am applying here, b square minus 4ac by mod a. Mod a is nothing but a only. That equals to, here gamma plus delta, sum of roots here minus q by p. Okay, na? Difference of roots, same way, root over q square minus 4pq 4pr by modulus of p. Numerator, that means there are two different fractions. Here denominator same cancelled, both also cancelled. Now we are having that minus b by root over b square minus 4ac, that equals to minus q by root over q square minus 4pr. This is nothing but discriminant, root over discriminant, am I right? This is also root over discriminant. So I can cancel both sides negatives. Apply squaring on both sides. It is b square minus 4ac means d1. That equals to q square minus 4pr is nothing but d2. So just cross multiply d1 by d2 equals to b square by q square. d1 by d2 equals to b square by q square. Okay, na? So this is our required answer. We need to find the ratio of this d1 and d2, this one, b square by q square. Okay, na? So please continue. And that's it for today, children. Thank you one and all. Have a nice day. Please finish and go.